Okay, hello everyone. Welcome to this webinar, which is called Implementing Biomethane in Transmission and Distribution Networks. It's hosted by Juran Benchmarking, and it's co-presented by Energinet and Evida, who both come from Denmark. It's good that so many people have registered and shown an interest in this event, so hopefully we'll have an interesting session today and some good questions at the end. So today you're going to learn about the Danish gas system and the introduction of biomethane into that network and the challenges that Energinet and Evida have faced along the way. So my name is Brian Ferguson. I'm the host today, and my co-presenters are Annette Munter-Hansen of Energinet and Nikolai Bjerg Jensen of Evida. The session will last approximately 45 minutes today. The presentation will take up about 20 to 25 minutes of that time, and the rest will be allocated for Q&A. You can ask questions at any time using the questions window. You should see in the bottom right of your screen a little circular icon with a question mark to question, so you can type in there. There's also a chat box beside it that you can use to ask, make any comments if, say, you're having technical problems or there's something not right with the screen, etc. So feel free to type in either one of those boxes as we go through the presentation, and we'll pick up the questions at the end. So let me just move on. So before starting the presentation properly, just a few words of introduction. So Juran Benchmarking, some of you know us, some of you might not have heard of us. So we've been benchmarking oil and gas production assets for about 30 years now, utilising and optimising our proprietary normalisation methodology, which we call the Juran complexity factor. It's a statistically robust and verifiable method for doing this, and we've found very strong correlation and accuracy with the data that we collect on that and the comparisons that we create for people. It's been very useful in helping clients justify things like strategic decisions and investments over the years. One of our key activities, as it says on the slide, is benchmarking consortia. So these are group programs that we've been running now since about 2005. They have two main areas. One is the KPI performance benchmarking, which we use to collect and then compare the participants. But the other area is best practice sharing, where the companies involved share expertise and experience, and they do that freely in the group, and that enables them sometimes to solve problems together, to learn from one another and move forward with say issues or challenges that they may be having in their own country and people from other places could help them solve those things. So in 2025, we're looking to start a similar program for gas distribution, but the transmission one is known as the GTBI, and that's been running since 2005. Energinet is part of that group, and that group now covers approximately 80% of the European transmission network. So it's been very successful, and that's what we're hoping to replicate with the gas transmission in the future. So today's webinar is focusing on a topic that's a kind of example of the kind of things that we talk about in those group programs, albeit today we'll be at a higher level because we don't have the the time to go into such a depth that we would in the consortia environment. But never mind, I think this will still be a very useful and interesting and educational session today. So Energinet, as I said, are Denmark's publicly owned gas transmission system operator, and Evida are Denmark's publicly owned gas distribution system operator, DSO. So I won't say any more about those two companies because Annette and Nikolai will tell you more as we go through the presentation. So with that, I'll pass on to Annette to start the presentation.
Yes. So quite a lot has happened with biomethane in Denmark during the past decade, and Nikolai and I will tell you about how we have handled it together as the DSO and TSO in Denmark. First, we'll give a short introduction to the Danish gas system and what has happened with biomethane in Denmark, where we see it in the future. And then we'll tell you about the technical stuff we've done to be able to handle this growing amount of biomethane in the gas grid, how we've cooperated about it, and what secondary issues with gas quality we are seeing and handling. So first off, Nikolai, you'll tell about the Danish gas system.
Yeah, I think it's important to take a quick introduction or view into the Danish gas system. There came. What is special in Denmark, I guess, is that we're only, like Brian and said, we're only one TSO and one DSO, which is maybe not that often, at least not in our neighboring countries. But as you see, the Danish gas grid is, in my opinion, quite widespread. The main reason for developing the gas grid in Denmark was the oil crisis back in the 70s, where we wanted in Denmark to be independent from the Middle East and the oil down there. So we had our own natural gas from the North Sea, and we used it especially for space heating. Denmark also had have a lot of district heating, and we used the natural gas in motors and boilers back in the days. It's not a big part anymore. Energinet is, I guess, a classic TSO. They're taking care of Denmark's foreign connections to Sweden, Poland, Norway, and Germany. What they also do is that they're actually operating two gas storages, and then they have connected a single biomethane plant. Evida is supplying most consumers in Denmark, and we are also sort of like the main connector of biomethane plants. If you take the other slide, Brian. If we take a further deeper look into the biomethane plants, they are mainly located in the western part of Denmark. That's probably due to the biomass resource, especially according to manure from the agriculture. And as you see, we have in Evida connected 57 biomethane plants, and I said that Energinet has connected one. The TSO storages are split up to one is based on a cavern storage, and the other one is an aquifer storage. So that's the overall Danish gas system.
If we take a look at what has happened with biomethane in Denmark, during the past decade, we have gone from having no biomethane production, and today we have around 8 terawatt hours per year of biomethane production. And during the same period, gas consumption has decreased quite a bit, especially during the energy crisis in 2022. So today the annual consumption is around 20 terawatt hours per year, giving a biomethane share currently of almost 40%. So that has required some significant grid adjustments to be able to handle these large amounts of local biomethane production. The political ambition is to go even further. There should be more biomethane production and further decreasing consumption, so that in 2030, at the latest, we should be at 100% biomethane share, probably even surpassing that later on. That's what this little green cross, as our politicians fancy calling it, means in the figure. No, it's fine. If we look a little closer at the expectation for the gas consumption in the future in Denmark, the political ambition is that gas shouldn't be used for private heating in the future. That should be heat pumps, district heating or something. So gas should primarily be used for industry in the future. And that's an important factor when we are talking about handling biomethane, because the audience today should be mostly DSOs and TSOs, so it's not a big surprise to say that gas consumption is generally higher during the winter because of gas for heating, and lower during the summer where there's no need for gas for heating. At the same time, biomethane production is pretty much the same the entire year. So in Denmark, when we're talking about handling biomethane, that's mainly during the summer when consumption is low and biomethane production is relatively high compared to that. But if in the future gas is primarily used for industry, that consumption is more stable throughout the year. So we expect to have to handle surpluses of biomethane for a larger and larger extent of the year in the future if it's mainly used for gas consumption. You can change the slide. A question I've often been asked by foreign TSOs and DSOs is what has been the cause for this steep development in Denmark? What has been done to support this development? And of course, a big part of the answer to that is subsidy scheme, as in many other countries. In Denmark, there hasn't been any direct subsidy for building the biomethane plant, but there's been a fixed rate for quite generous rate, I think, because it was an early technology for every normal cubic meter of biomethane produced. So the biomethane plant could be guaranteed a certain income from that, aside from anything they would be able to sell. Then, of course, there are the green certificate, the guarantee of origins that can be sold by the biomethane plants. And then in Denmark, we have chosen to have relatively favorable gas quality requirements for biomethane, in the sense that it still has to have the same gas quality as is required for fossil natural gas, and we need to protect our system. But we haven't made more restrictive boundaries on some compounds, such as oxygen, than we have deemed necessary, so that we have tried to make it possible for the biomethane plants to produce within those gas specifications. Then it is mandatory in Denmark for the DSO and TSO to connect biomethane plants to the gas grid. We can't just say, no, that's inconvenient, we don't want it. We have to together find the best and cheapest place for the biomethane plant to be connected to the gas grid. Then the biomethane plant pays any directly associated cost, but any cost for general grid reinforcement, grid adjustments due to that biomethane, that's paid for by us as the DSO and TSO. And then in general, during this past decade, the industry in itself has gone through a lot of development and optimizing itself to have lower operating costs. So that has also supported this development. If you change to the next slide, Brian, just to emphasize that. If we look at what has happened with the biomethane industry in Denmark during this past decade, which has also been, again, supported by this subsidy scheme and such. Originally, the biomethane plants connected to the grid, they were relatively small, at least by Danish standards, like 300 normal cubic meters per hour. They were owned by local farmers as a small additional income to the plant. Perhaps they were curious about the technology, but more as a side business. And then they have started grouping together more and more farmers, so they had more biomass, they could build bigger plants, getting economy of size. They might be able to hire some professional people to operate the plant, optimize processes, optimize the purchasing of biomasses and selling of products. So there's been a lot of optimization going on, starting to have private companies buying the biomass, building the biomethane plants. So today there has been this whole development of large companies owning and operating several very large biomethane plants in Denmark with optimized everything. And normal plants built today are 2,000, 3,000 normal cubic meters per hour with some even bigger and much larger in pipeline in Denmark. So this whole process has also been part of the reason for the success of biomethane growth in Denmark.
Yeah, and if we're taking a more technical look at the biogas sector and the biomethane plants and how these are connected to the grids, then we in Evida have two different approaches, at least when we look back in time, and that's due to the fact that Evida is a fusion of several DSOs which had different approaches. In some geographies of Denmark, the biomethane plants were connected via a 4-bar pipe directly into this lower pressure grid at Evida, So they were delivering gas directly into the consuming grid, if we could call it that, at this 4-bar grid. And another approach was to build a separate connection to the metering and regulation station, or measuring and regulating station. And then it was injected directly into the 4-bar grid. So both approaches were focusing on using the biomethane locally because that's beneficial according to compression and so on. But there was this slight difference. Today we're only using the 7-bar grid connection. And if we're checking the next slide, you can see that some of the benefits from this 7-bar grid connection is that we are able to mix and measure the delivered gas in the grids simply because we can control the mix, while the 4-bar connection then it's mixed out in the grid, and we're not able to bill or calculate the customers correctly simply because it's mixing, and we don't know who gets biomethane and who doesn't get biomethane. And that's an issue that this 7-bar grid connection solves. And we also set up compressors simply because the local consumption is in most cases not big enough at the main part of the year. So Evida is compressing the biomethane from our low pressure grid and onto our high pressure grid, which is dimensioned at both 19 bars in some parts of Denmark and 40 bars in some parts of Denmark. And the next slide will show you what happens when they are even going beyond our grids, because we, like Annette said, we are now looking into to quite big plants producing heavy amounts of biomethane, which is great. But it also means that we have big geographies and regions in Denmark that, especially during summer times, simply is filled up with surplus biomethane. So when Evida is compressing the biomethane towards our high pressure grid, this is also filled up, and in some grids, even during winter time, we also need the compression towards the TSO grid. So Annette and her colleagues are also building compressors. We usually call them reverse flow stations or plants, and they are taking the surplus gas from the DSO grid and moving it towards the TSO grid. And at least the balance is fixed when we have put it on the TSO grid. But it also it causes some other issues. I think Annette would introduce you to. The grid connection is paid by the plant owner, while the compressors is paid by the two grid operators. So Evida is paying for their compressors and also the operating costs, or the OPEX, for the compressors, and so do Energinet. And would you tell more about these reverse flow station?
Yes, as Nikolai mentioned, at some point there simply isn't consumption enough in the distribution grid, even when Evida tried to move it around. So at some point we have to move the surplus of biomethane into the transmission grid, so it can go to other parts of Denmark, to storage, export to neighboring countries, or whatever, somewhere not in that distribution grid. And we do that by building reverse flow stations. And this picture shows one of our reverse flow stations, and what they do is that we remove the odorant. There's odorant in the distribution grid, but not in the transmission grid in Denmark. So we have to remove that. Then we compress it to transmission grid pressure of 80 bars. That makes the gas hot, so we cool it, measure gas quality, and then it can go into the transmission grid. So that's sort of the standard build something to solve the issue solutions that we have. What we see today, as I explained earlier, is that the biomethane plants are getting bigger and bigger. And historically, these smaller biomethane plants, they've been connected all out at the farther reaches at low pressure in the distribution grid. But as they become bigger and bigger, it's getting more and more difficult for the local consumption to be able to handle those amounts of biomethane. And especially with these very large plants, we look into not even connecting them at higher pressure distribution grid, but perhaps all the way up at the high pressure transmission grid directly to be able to handle simply the amounts of biomethane being connected with those plants, that it might be the better solution in some cases. If we look at the Danish gas system as it looks today, the white lines here are the transmission grid, the grayish lines are the higher pressure distribution grid, and the funny dots are the reverse flow stations that we currently have. As you can see, most of them are in the western part of Denmark, because as Nikolai explained earlier, that's where most of the biomethane production is. So that's what we have today, these 5 reverse flow stations to handle the current surpluses of biomethane in these parts of Denmark that we see today. But with the political ambition of 100% biomethane, we need to build more reverse flow stations. And to make the best plan for this, we as DSO and TSO have sat down and cooperated on finding the best solution from a total gas system perspective to make the necessary grid adjustments. And I think you'll explain that, Nikolai.
Yeah, I would also say that both Annette and I in Energinet and Evida has a very close cooperation, and we see each other several times during the year to cooperate this. And one of the, I wouldn't say conclusions, but maybe the solutions back in the day to solve this problem was to for Evida was to merge some of our high pressure grids. One of the benefits is, of course, that if you have surplus biogas in one grid and you have a need of consumption in another one, you could just let it flow towards the consumption. That's, of course, one benefit. But when we're combining and merging our grids, we're also able to sort of like share these reverse flow plants. So instead of building or making in Energinet building 3 of these reverse flow plants, well, we can combine 3 grids, which then share one reverse flow plant, which makes sense because both at least reverse flow plants are really expensive, but these grid connections are just expensive. But it's very costly on both sides. So close cooperation is needed, also not to make any bad decisions simply because it costs quite much. Currently, we have finished one of our grid connections. That's the not dotted yellow line in the bottom. And then we are currently making 4 other grid connections, which will integrate and merge some of our grids to one.
And then at the same time, we at Energinet are building 6 new reverse flow stations, so that almost all of the distribution grids in Denmark have 1 or more reverse flow stations to handle any future surplus of biomethane.
I could maybe say that there were these black grids, and I don't think Annette explained it, but we have some small high pressure grids at Evida, and the consumption is so low that it doesn't make any sense to connect biomethane plants in these areas, simply because it would need maybe a reverse flow plant for one single biomethane plant, and that's not very cost effective. So we are trying to make it strategic and connecting them where it makes sense. So yeah. Now we've talked a lot of the connection of biomethane plants, and it's of course a good thing, but there's also a lot of issues related to it. I said it before, we have some mixing of gas qualities. This is I would say it's the biggest high pressure grid in Denmark, at least Evida's high pressure grid. I think it contains around 20 biomethane plants. And as you see, there are some yellow areas and there are some green areas. And that's the differences in the CV, so the calorific value. And we need to control this calorific value to bill our consumers correctly, because in Denmark, at least, the Danish biomethane has a CV of around 11 kilowatt hours per normal cubic meters in upper CV, and the Danish North Sea methane has a much higher CV. So we need to take care of who gets what kind of gas. And the way we have solved that is to implement this quality tracking software, where we simulate and calculate the gas flow, and by that also the CVs, so we know, at least based on the model, who gets what kind of gas, and by that we're able to bill our consumers correctly. And it's based on this entry and exit points. So we set up all the exit points and all the entry points, and by that the model knows where the gas flows. And it's actually done every single day, or the model is calculating every single day. So that's how we've solved this in Evida, and it's an important part of integrating biomethane plants in Denmark. And then?
So when we're talking gas quality in the distribution grid, as Nikolai said, it's very much a billing issue. But as we have more and more biomethane in Denmark, and more of it ends up in the transmission grid through reverse flow stations, we also start seeing these gas quality changes in the transmission grid. And for us, it's very much also an issue due to that with the transmission grid, we also need to export our gas to our neighboring countries. We are connected to storages where that gas will end up. And there could be industry that's sensitive. We don't really have much industry that's sensitive to gas quality like that in Denmark, but I know many other countries in Europe might be more sensitive, especially if the gas is used as a substrate for the process and not just for burning. So, biomethane has a gas quality very close to fossil natural gas, but there are small variations that can cause concern. The primary one being talked about is oxygen. Fossil natural gas doesn't contain any oxygen, but biomethane contains some oxygen. In Denmark, we have decided that the limit for injecting biomethane is 0.5% of oxygen. Actual levels are generally lower, like 0.1, 0.2%, but still a lot more than natural gas, fossil natural gases. And when we want to export our gas to neighboring countries, for instance, Germany, which has quite a lot stricter limits on oxygen, that can cause issues. That there are also European concerns about oxygen in gas storages and whether they can be harmful for the gas storages. So we're looking into what to do the best with handling oxygen for these various issues. Another factor is hydrogen. There are small amounts of hydrogen in biomethane, but the main reason that we look into it is because of e-methane. E-methane is produced from green hydrogen combined with CO2, for instance, from biogas plants. So you can use methanation and produce more methane, e-methane that can be injected in the grid. We had the first such plant connected to the distribution grid a year ago in Denmark. And there's no reverse flow station there yet, but there will be in a few years. And there's somewhat significant hydrogen slip from that process, so that hydrogen will end up in the gas grid, in the transmission grid. And again, there could be issues with exporting to neighbors, where they can cause issues in the storage and so on. Finally, there are, biogas and biomethane are an Easter egg of funny small trace amounts of all sorts of things that could or could not be problematic in the system. One such is terpenes, which can be there due to certain biomasses in the biogas plants, and that can mask the smell of the odorant, so you have to add more odorant to be able to smell the gas. And there are other things that we might find out in the future that we need to look further into. So just to say that there are several things that need to be also considered, aside from just the amounts of biomethane, when we're talking about integrating biomethane in the gas system. So just to sum it up, we've had quite a rapid growth in biomethane in Denmark during the past decade, almost 40% now. To a large degree due to subsidies, but also various other factors to support the growth. And the plan is to be at 100% biomethane share in 2030 at the latest. That has required significant grid adjustments that we need to plan for and cooperate together, DSO and TSOs, to do as optimal as possible. And even when we have handled the sheer amounts of biomethane and balancing the grid, there are some secondary gas quality issues for calorific value, for various trace amounts that needs to be considered when billing customers, when exporting, putting in storage, and so on. So a lot of stuff has been done and a lot of stuff still to do. I think that was all for us, and we are ready for questions.
Okay, well, thank you, Annette and Nikolai. That was great, very interesting. I'd now like to check and see if we have any questions from the audience. Let me just have a look on the system, see if anybody's typed anything. Okay, here's one. So, how do you handle off-spec gas from biomethane plants? Are they allowed to inject off-spec in the system for a certain period, or are they somehow compensated if they're not allowed to do that?
Should I take that one? And then
that's mostly for you, Nikolai, because most of the biomethane plants are.
Yeah. We're actually just cutting them off. We're measuring the gas the entire time in this biomethane receiving station, and if they're out of spec, we're just shutting them off, and they can decide if they want to recirculate it and clean it up, or they can just flare it off. We actually don't care. But when the gas is on spec again, they can freely inject it to the grid, and they are not compensated. Both when it comes to being out of spec, but also we had during the last few summers we had some grids where we actually were able to lowering the biomethane production simply because we couldn't contain more gas in the grids. The pressure was increasing, and then our control center called the biomethane plants and said, hey, we're in need of you lowering your production, otherwise we have to shut you down. And in that case, they won't be compensated either, even though you could say that it's Evida's fault, but it's the limitation of the infrastructure. So no compensation. I hope that was an answer to the question.
Okay, great. Thank you, Nikolai. I think here's one for you, Annette. What program is used to calculate CV in the transmission system? Is it Simone?
Yes, I believe that's what's used. It's not something I sit directly with, but I know a lot of my colleagues work with Simone, and I believe that's what's being used for calculating not just CV, but also other gas quality features in the system.
Okay, great.
Maybe I should add it, Brian, because we're in Evida, which I guess it's much more it's more a complex grid than the TSO, and according to like Simone and in our case SmartSim, we use the quality tracking software called SmartSim, and we still use it, but we're also looking into using Simone because we can combine the grid planning and calculation tool with the quality tracking tool. So currently we're actually setting up this Simone, but historically and still we're using the German company called SmartSim, which has, I can say that it's a good simulation tool.
Okay, great. On that subject, I've got another question about SmartSim. It says, is it an issue for your SmartSim tool when the direction of flow alternates at the transfer points between TSO and DSO?
Is it my desk again? And you're muted.
I'm not sure quite caught the question, but yes, you feel free to answer, Nikolai.
Okay. Yeah, I think it's relatively easy to handle actually, because you can see it as a consumer. We know what's taking out of the grid, and if it's a reverse flow station or a large consumer, that doesn't make any difference. What makes a difference is that if we're not able to to know, or at least be aware of the balance, so what's injected and what's taken out of the grid. That would be an issue, but we actually don't care who's using some of our gas or removing some of our gas. And we haven't connected the simulation tools between Evida and Energinet. So Evida is only looking into our own grids, while the TSO and Energinet is only looking into their own grids. So for us, it's easy to handle.
Okay. Yeah, there's a few more coming in now. So next one, do you issue any derogations for oxygen and hydrogen for biomethane producers?
I mean, we have the same gas quality requirements for biomethane producers as we have for any gas entering the Danish gas system. We have some specific limitations for instance, oxygen. There wasn't really any limitations on that for fossil gas due to no oxygen there. So we have set a specific limit there of 0.5% for biomethane. There hasn't really been any specific limits on hydrogen, I believe, other than that it shouldn't be there, but we are currently working together with various ministerial agencies on fixing a specific limit for hydrogen, because we're starting to see this e-methane and other things that requires a fixed limit for hydrogen.
Okay. Next one, who pays for depressure stations, the TSO or the DSO?
For what kind of stations, sorry?
It says depressure.
Are you aware of what
Depressure station, that must be the stations?
Yeah, perhaps. Yeah.
The measuring and regulation stations depressurizing the gas and sending it into the distribution grids, they are owned by Energinet and paid for by Energinet.
Okay, great, thank you. Next one, are you in a position to share which software is used to monitor CV quality?
Yeah, I think I said it in both cases, actually. Both Evida and Energinet has used the Smart Sim tool, but is currently looking into the Simune tool.
Okay. A few more. Who pays for the extension for the connection, the producer or the DSO?
I'm not quite sure what extension means. I mean, the direct connection between the biomethane plant and the distribution grid, that's paid for by the biomethane plant.
Okay.
Actually, in Denmark, I could elaborate a little bit. In Denmark, according to the biomethane plants, the grid connection is paid by themselves, but actually it's owned by Evida, which sounds a bit odd. I'm aware of that, but we can't couple any or connect any other biomethane plants to it, so it's relatively irrelevant. But that's the case. Evida owns it, but it's the operator who actually pays for it.
Okay. Excuse me. What are your plans for hydrogen admixtures in the future?
I don't think we have any direct plans. I mean, from a Danish perspective, we don't see much point in mixing hydrogen in. Not to say that someone won't decide to do it, but currently we are keeping the limit for hydrogen concentration in the gas grid low, meaning that there won't be much hydrogen injection allowed. Do you have anything to add, Nikolai?
Yeah,
my impression is that the plans are still quite low.
I agree totally. We don't look into injection, and both companies are actually looking into developing separate hydrogen infrastructure. So this mixing part is not a part of the Danish agenda. We're looking into a whole new infrastructure containing Danish green hydrogen.
Okay. Let's see, I think there's one or two more. What's your perspective on potential connection points for remote biomethane units such as CNG/LNG?
But if it was about injection, I don't think we have any injection of CNG. Actually, we get if we receive any CNG, it's from the German border in Denmark. But we currently have consumers that produce CNG mainly for transportation. But Evida is also connecting an LNG plant. There, the purpose is to produce liquefied biomethane. Is it actually for the marine industry? So it's mainly on the consumption side that we are facing compressed gas and liquefied gas, not as a source of gas.
Okay. So here's another one. From a statistical point of view, how long or how many times have you had a situation where you've had to cut the biomethane plant off the grid because of a technical problem from the biomethane plant side?
That's a tough question, because I think it very much depends on the different plants. They are able to operate at very different. I think I would say relatively often, but then it's maybe just in, let's assume, 5 minutes. And if they are recirculating the gas, I don't think it affects the plant that much. But it's not, just one single time during a year. It happens for sure. But I wouldn't consider it as a problem. It's just a part of injecting biomethane into the Danish gas system. And it's also not an issue between the biomethane plants and us. We never discuss it actually. What we discuss is these imbalances during summertime, where we have to reduce the biomethane plants for longer periods, potentially a few weeks. That was the case last year. And in both Evida and Energinet is important in that discussion, simply because I could tell that last year, actually, the reason why we had to lower the production from the biomethane plant was it's Evida who's doing it, but the main reason was actually one of these reverse flow plants at Energinet who broke down. So both grid operators are active in having a dialogue with the sector, and we are setting up meetings in late spring to discuss and tell what we are looking into this summer. So that's much more important for, I think, both the operators, Energinet and Evida, and also the biomethane plants.
Okay, I think an important factor here might also be, Nikolaj, that again, we have a relatively mature biomethane sector in Denmark, and my impression is that most biomethane plants are quite attentive to these gas quality requirements and other things. So they keep close watch on those themselves, measure it themselves, and preemptively try to react to any such problems. So they're very much part of making sure that there are no issues, and perhaps even stopping injecting themselves if they see issues.
Okay, great. Well, we're kind of coming to the end of the time, but I think we've maybe got time for one more question. Hopefully it'll be a fairly short answer for you. So somebody's asked, how do the reverse compression sites work? Are they operated by the DSO manually, or are they telemetered to the biomethane plants, monitoring outlet pressure in the network and operated automatically?
I don't know if it's us who owns and operate them, Nikolaj, but it's Evida that very much communicate with the control center. But it's a matter of when the pressure gets too high in the distribution grid, then the reverse flow station starts.
Yeah, we have a set point. Let's assume in a certain grid it could be 30 bars. So if the pressure increases to 30 bars in the Evida high pressure grid, the reverse flow plant will start and try to lower the pressure until it reaches, for example, 26 bars, and then it will shut down and wait until it reaches 30 bars again, and so on. It will keep going on if there's a surplus amount of biogas. If there isn't a surplus amount of biomethane, it won't start. And that's where we also have a very close cooperation, simply because it's the need from Evida, but it's actually the operation from Energinet. So we're very much dependent on each other.
Okay, great. Well, I think we'll wrap it up there. So thank you very much both to Annette and Nikolai for their excellent presentation and handling all the interesting questions at the end. It's really appreciated. If anyone, well, just to note, once this finishes, then there will be a link available. The recording will be made available. So you should receive an email telling you about that later. If for some reason you don't get that and you want to see the recording, please get in touch with me at Juran Benchmarking, and I'll help you out with that. So all I say is thanks everybody again for attending today. I hope you've enjoyed it. I hope you've learned something, and thank you again to Annette and Nikolai for their time and their wonderful presentation. So with that, I'd just like to say goodbye. Thank you.